In this video, we are going to practice lots and lots of questions of finding the gradient of a straight line. And you might also come across it like this, change in y over change in x. I think you would see that in physics. I think you're dealing with speed when you're looking at that. Anyway, let me not try and do physics. What does it mean if I look at this one over here? If I look at my formula there, it means that we need two coordinates to be able to calculate the gradient, the steepness of a line. My second coordinate's y value minus my first coordinate's y value, so the change in my y values, the difference between my y values, and then over the x value of my second coordinate, and I take away the x value of my first coordinate. We're going to practice this together just now. Right. Helpful information is that if we've got a straight line, there we've got straight line AB or whatever, or let's rather say there's point A, there's point B, there's point C, and there's point D. If you think about it, a straight line is just made up out of a bunch of lines that are so close together, so a bunch of points, made up of an x and y coordinate that are just so close together that they form a line. Now, the thing with a gradient is that it is consistent for a straight line. What do I mean by that? If we were to get the gradient between point A and point B, it would give exactly the same answer if we try and get the gradient between B and C. And if we get the gradient between D and C. So a straight line has a constant gradient. The gradient doesn't change for a linear function. All right, now let's jump in and do some of these examples. I think altogether there's 8. So we are going to be so good at finding the gradient and also maybe a little bit tired of finding the gradient. Let's go. If we look at the first question, there it says that we need to calculate the gradient of the following lines. Over there, grade 9, I put in the coordinates for you there, but you must be so good at reading the coordinates accurately off of the Cartesian plane. So if we look at the first line, if we want to find the gradient, it would be the change in our two y values over the change in our two x values. Now, let's just use the two coordinates that we were given there, but we can also use that point over there and use that to find the gradient, because no matter which 2 points on a line you use, it will give you the same gradient. So that's all good, just as long as you can clearly read it off and see what it is. We're not going to use something that's randomly in the middle of nowhere there, because then we're going to have to estimate. We don't want that. All right, so we've got those two. Let's get the change in our two y values. Doesn't matter which coordinate you start with. So I am going to use that one and that one, my two y values. I'm going to take 7, take away 4. And then I am going to say 0, start with the same point, and I am taking away a number that is already negative. That will give me 3 over positive 9, which is equal to a third. So my gradient is 1 over 3. So that means for every change in y, which would mean a vertical shift, so either up and down, for every one shift, up or down, I will move 3 to the side. Let me show you what I mean. So if we look at that, if we take between those points, so I've got 1, 2, 3 units that I moved down. I move 1, 2, 3, 4, 5, 6, 7, 8, 9 units horizontally. I've got that it's 1 over 3. So where does that come from? Well, it's just in its most simplified form. So my change in y, if I move 1 down there, I will move 1, 2, 3 to the side. Are you going to have to go draw in those squiggly lines? I doubt it, but we're trying to get a good understanding of the gradient and how it works so that we can also apply our knowledge when we get to those problem-solving questions. Okay, there's the gradient for line 1. Let's look at line 2. The gradient, for that one, we need 2 points to be able to calculate the gradient. We can also use, well, whatever point that we can see we are clearly going through. So we can also use that one, doesn't matter. All right, I'm going to use these two because they're already there. Doesn't matter which point you start with. Y minus y. Start with the same point. X minus x. That gives me 5 over 5, which is just 1, a gradient of 1. So for every unit that I move 1 up or down, I will also move 1 to the side. Gradient of 1. Let's look at the third one. All right. Ooh, we don't have any points on the third one. Well, we can quickly fix that. Let's use that point over there. Let's use something different. There, my x would be 0 and my y would be 1, 2, 3, 4. And let's use that point over there where my x would be, I completely swapped that around. Silly. You see what I did there? You noticed that, didn't you? My x is 4 there, and my y is 0. Make sure that that does not happen to you. And then my x is 5, 6, 7, 8, 9, and my y is -1. Also be mindful of those signs. So my gradient for line number 3, if I use those 2 points, would be, doesn't matter which one you start with, I'm going to say -1, take away 0, 9, take away 4. And that would be a -1 over, is that 5? Yeah. So there is my gradient. It also makes sense that it's a negative gradient, doesn't it? If you think about the previous video and where you have a negative gradient, the direction of the line. So that would also mean for every single unit that I move up or down, I move 5 to the side. So if we start there, 1 down, 1, 2, 3, 4, 5 to the side. And there's my next point. Then 1 down, 1, 2, 3, 4, 5, and there we go. Definitely accurate, and it's constant between those 2 points. 4. We need 2 points to be able to calculate the gradient. Those points are given. Let's just use the ones that are given. We've got that point over there and that point over there. Doesn't matter which point you start with. I'm going to start with -10. And then I am subtracting a value that is already negative. It's so important. Then it will be 7 and take away 2. Make sure that you track with what I'm doing there. Then it becomes -10 and I plus 2, which would be -8. And then I've got 7 and take away 2, which is 5. So it makes sense that there's also a negative gradient there. Let's just quickly see if it works and that I didn't make a silly error there, or maybe the coordinates are wrong. If I am moving 8 up or down, I'm moving 5 to the side. 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 2, 3, 4, 5. Now, that looks pretty good, and the negative gradient makes sense. We can move on. Now, I don't know about you, but if we look at 5, I would say that that is a special line. It is just horizontal. There isn't the steepness. Can I say that even? There isn't a slope. There isn't a gradient. It is like flat. It is, yeah, no gradient. The gradient is 0. Can we prove that? I mean, by using our calculation. Let's see. So I've got 2 points there. -6 and subtract something that is already negative, and then -4 and take away that, which would give me 0 over 4, I think, which is just 0. So the gradient is in fact 0 because we don't even have to go work that out. There isn't a gradient. It's flat. Okay. Let's look at 6. 6 is also pretty special, and we will be talking in how many lessons from now? We are going to be looking at those special lines, your horizontal and your vertical lines, where I find that students make a lot of mistakes, and then they also make the same mistake in other sections of the work. If we look at 6, there it is. It is just a vertical line like that. What do you think that gradient is? Do you think it's also 0 maybe? Well, let's use a running analogy. So let's say walk. So if you go for a walk, if it's a 0 gradient, it's just horizontal. It's flat, there's no resistance, it's a nice easy stroll. But then when there's a gradient, it's like walking up a hill where it's a little bit harder. And then think about it with that vertical line. It's like walking up into the air. We can't walk straight up into the air. So with that, our gradient is undefined. It's undefined. Let's use our formula and also just show that. For our gradient, if we get the change in our y, that is, it would be 2 and take away a number that is already negative. And if I start with the same one there, it would be -4, and I subtract a number that is already negative. Okay, if we simplify that, that would give us 4 over negative 4 plus 4, which is 0. And can't have that. Can't divide by 0. That is why our gradient is undefined. All right, so that is calculating the gradient. If you have got lines drawn on the Cartesian plane, you need to read 2 coordinates off of the line and then calculate the gradient. Then they can also just give it to you like this, where you don't have the Cartesian plane, you don't have a line drawn, but you have to go calculate the gradient. It says that we need to find the gradient for a line that passes through those 2 points. Well, we know that we only need 2 points to be able to calculate the gradient of a line, and we just need our gradient formula. So the change in our 2 y values would be 4 take away 2, 3 take away 1, and that would be 2 over 2. So that would just have a gradient of 1. Am I right there? Yeah, I think I work accurately. So there the gradient will be 1. For the second one, I need the gradient for that line. Change in my 2 y values. It would be negative 5 and I take away 4. And then negative 3 and I take away something that is already negative. And that will become negative 9 over negative 3 plus 2, which is negative 1. And there we've got a positive gradient of 9. So that is a proper steep line. And there you go.